morning, everybody. Welcome to our webinar series hosted by Enercon Engineering. This is our first webinar of 2021. So we are excited to see you. And I see we have some returning viewers. So I want to say thank you for joining us. And it's great to see you virtually in the new year. So great to see you. We also have some new viewers, and I want to thank you guys for joining us. And I just want to tell you a little bit about Enercon before we get started. Enercon is located in East Peoria. That's where we do all of our designs, our manufacturing, and our testing. We have a 160,000 square foot facility there. There we have produced over 40,000 products, not only domestically, but around the world and in 110 different countries. I'm your host, Sean Lott. I am the Director of Business Development. I'm actually located in the Enercon Business Development Office in Huntsville, Alabama, that we stood up last year. So we're coming up on our 1-year anniversary here in a couple of months. In 2020, we decided to do these webinars. So we've hosted 6 webinars in 2020. So this will be our 7th. If you missed any of those webinars, you can view them on demand on our YouTube page. So all you got to do is go to our page, and I put the link in the chat box so you all can see it. So you just click it. It'll send you to our YouTube page, and you go to the webinar playlist, and there you can see the 6 videos that we have produced thus far, as well as this video. Once it wraps up, when we do some small editing, we'll get it posted as well, so you can view it at your leisure, or you can share it with your friends and coworkers. Before we get started, I also want to let you know that you can ask questions during the presentation by clicking the Q&A tab there on the Zoom toolbar. And I will read the questions to Jason as the questions are posted, if it's relevant to what he's saying. We'll answer those in stride. If not, then I will hold the questions and table those to the Q&A session at the end. But I promise you, one way or another, we're going to get your questions asked and answered today. And if it's something that we just don't know at the moment, we'll go and we'll research and we'll get back to you as quickly as possible, so you get your questions answered. Just as a reminder, this is also being streamed live on Facebook. So you can also go to Facebook, if you're not already there, to see this as well. So I want to thank you for tuning in. And now for the main show. I would like to introduce to you today's presenter, Jason Olszewski. Jason is from the great state of Dayton, Ohio. He holds an associate's technical degree from Illinois Central College. After serving in the Navy from 2001 to 2006, Jason joined the Enercon team as the electrical technician and project electrical engineer. He is currently our switchgear and electrical controls regional sales manager for our West Coast territory. So Jason, the floor is yours.
All right, thank you, Sean, and good morning to everyone, and welcome to our webinar series here. And I'd like to go ahead and get right into this, as we got a lot to cover here today. So today we'll be discussing the differences between switchgear, switchboards, and panel boards, and what the difference are between these 3 pieces of equipment. The purpose and organization within electrical power system, as we can see here, in this diagram, we are looking at examples of a basic distribution system. And you'll see this layout similar in hospitals, high rises, water treatment plants, and large manufacturing facilities, just to name a few. And we'll go to the next slide there, Sean. So these are the 3 main options for organizing, housing, and utilizing overcurrent protective devices within a facility. So also known as OCPDs, these will either be fused or circuit breakers, and they protect primarily against overcurrent flow and short circuits. Circuit breakers are by far the most common, as they can be reset and used again after a fault condition is present, whereas fuses cannot be reused and require replacement at the cost of a new fuse. NEC Article 240 states that all electrical conductors shall be protected. So an overcurrent or short circuit faults, if not interrupted, can lead to damage to equipment and even fires in that facility. So fault studies are also required for an opacity with withstand ratings or fault current, circuit breaker sizing, and overcurrent set points. And we'll get into some more of these items in more detail in the next few slides. So switchgear is the largest of the three, as it contains the highest amount of current draw back to the utility source. Medium voltage switchgear tops out at 38 kV and is usually a larger footprint than low voltage. NEC defines switchgear as an assembly completely enclosed on all sides, top and bottom, with sheet metal except for when ventilation openings and inspection windows are utilized for that gear. The switchgear interior is accessible via doors, removable panels for front and rear access and for side access during installation and our maintenance. Switchgear contains primarily power circuits for switching, interrupting devices, busing, cabling connections, and oftentimes some level of intelligent controls will be used. All right, Sean. All switchgear will have a short circuit withstand rating, and this is based on a time frame of up to 30 cycles or half a second. The amount of short circuit fault current that the mechanical assembly, electrical bus, and bracing can endure for 30 cycles without sustaining damage at that particular tested voltage, and that really defines what we're describing here as far as short circuit withstand rating. Breakers can either be manually or electrically operated, and often draw-out type breakers are preferred for ease of replacement. And we'll get into more of that as we go on here. Main bus is typically up to 6,000 amp. That's really where we're going to top out there for main bus. Working with the breakers energized, there's definitely caution that we would want the operator to take as far as dressing out and wearing the proper PPE when you're working on energized, and now even consider adding a functionality of low arc mode, and energy reduction also helps provide extra protection to that operator. NEMA ratings for environment, and these typically are ratings of NEMA 1 and NEMA 3R. NEMA 1 you would see mostly for just an enclosure, for switchgear or switchboards that are inside of a building. And then NEMA 3R, you would see that as an outdoor piece of equipment, protection for that. So most commonly, switchgear breakers are equipped with solid state trip units. For example, you may see a spec requiring LSIG breakers. These letters signify the type of protection and available adjustments on that circuit breaker. So the L stands for long time, and that's what you would use for overcurrent or overload protection with a long time set point. S is be short time. So that would be some sort of a short or short circuit fault. I would be instantaneous, so that's a high level fault, and that's going to be your shortest time frame. And then you also have a ground fault protection there with the G. And so assembly may include control and auxiliary devices, may provide some type of a main tie main configuration. There are several different configurations that you could use just based on spec requirements and what the site needs there at the facility. And there may also be generator paralleling controls. So for standby operations, you would have controls there for bringing up a generator in case you lose utility. Switchgear can also be set up for different UL standards, more so than panel boards and switchboards. In low voltage switchgear, we'd be looking at UL 891. And so that would be dead front switchgear and low voltage. And UL 1558 for 600 volt. Medium voltage switchgear also has a listing of UL metal clad switchgear. So that they all follow specific guidelines for the equipment used, and so each part and piece part within that switchgear would carry a UL recognized label. Okay. So on to switchboards. So this picture shows some different sizes and types of switchboards. As you can see, the one on the right has a main breaker called out. That could be called main breaker, principal breaker. And so for that particular switchboard, you would see the cabling would go directly to that main breaker. And then through that breaker would feed typically copper bus over to the distribution. Some of the breakers or some of the switchboards there on the left side may just have cabling directly to that bus. So to isolate that would be from the switchgear. With the main breaker, you get that local isolation capability. All right. So the NEC defines switchboards as a large single panel frame or assembly of panels on which they are mounted on the face, back, or both, switches, overcurrent, and other protective devices, buses, and usually instrumentation. Switchboards are similar to panel boards, both normally rated up to 600 volts, generally accessible from the rear as well as from the front, and are not extended or not intended to be installed in cabinets per NEC 100. Often only accessible to the front is required, and rear and side accesses may also be required. Switchboards are floor mounted, similar to switchgear, but they are deeper than panel boards, usually starting at 18 inches deep. Since switchboards are larger and more expensive than panel boards, they are seldom used for bus ratings less than 1200 amps. So they can be up to 5000 amps. So if you were, in a lower amperage there, you would probably go with the panel board in place of a switchboard. But as you get larger in size of your loads there, you're going to need that extra copper bus and space there. So you'd go with a switchboard. Breakers can be equipped with solid state trip units or thermal mag. Solid states are the most commonly used, as they provide they provide you with the ability to have different set points and times for that trip unit, to where a thermal mag it is what you purchase. So as you buy a 50 amp thermal mag trip unit with your breaker, that's what it's going to be there for, and it's just going to be what you purchased. So, but you can buy circuit breakers with bolt-on or draw-out type, and so bolt-on would be for a place high vibration or susceptible to vibration, and it'll help keep that breaker firmly installed there in your panel. All right, so onto the panel board. So here we can see a different range of panel board shapes and sizes. The panel board on your left, this would be what you would see, even at your house. We'd be looking, at probably a single phase there, 240, 120. So you'd see that for lighting loads and smaller loads. Some of the panels there on the right side, where you can see a main breaker, those could be 3-phase, and at 3-phase you'd be running a voltage of 208 and also 120 there off the single breaker. All right. Next slide, please, Sean. So the NEC defines a panel board as a single panel or a group of panels designed for assembly in the form of a single panel, including buses and automatic overcurrent devices. These can be equipped with or without switches for the control of light, heating, and power circuits, designed for a cabinet or cutout box placed in or against a wall, partition or other support, and accessible only from the front. These can be divided into load centers and panel boards. both of which are often referred to as panels. And so we can see in this, this picture, this example here, we have several different panel boards located within one enclosure. And so we're kind of grouping those together as for ease of access and less cabling there, just putting them all in one container. So panel boards are by far the least expensive way to accommodate circuit breakers. Breakers themselves are usually less expensive. They're mass produced, and they're just more readily accessible for purchase. Load centers are primarily intended for applications up to 240 volts and are normally only rated up to 225 amps. Some may be rated at 277, and this is not very common, but you can see certain lighting circuits in facilities where you've got three-phase 480, and you can go 277 line to neutral there for lighting loads. As required for NEC 408.38, they also have dead fronts, meaning that there are no live parts exposed. So on the front of the panel board, you can open the front door there, and then you'll have a panel protecting the operator from touching live parts or copper bus or connections. And that's also where you'll see the labeling for circuit designation would also be on that panel. So smaller panel boards can accommodate plug-in or bolt-on breakers. Larger panel boards only utilize the bolt-on style breakers as they're going to carry more weight, physical weight, and the bolt-on just helps to keep those in place. Circuit breakers most commonly used will have non-adjustable thermal mag trip units, as we discussed before. That really limits your ability to change time and set points, but you'll still have that same overcurrent and short circuit protection. All right, economics, they'll also often drive specifications regarding which type of equipment to use. So if you have any questions, if you're looking through a specification and you're not really sure, you can always reach out to an OEM manufacturer such as Enercon, as we'd be happy to help you and support you in that, choosing what to use. So the required space for switchboards or switchgear frequently becomes an issue. So based on the available footprint, your OEM manufacturer can also help you choose which equipment to use and where. So in order to meet the utility service requirements or to save space inside, often the main service switchgear is mounted outside the building. So this is where you would take into consideration the NEMA rating. So you would want NEMA 3R if you're outside, or you could also sometimes see what would be called an E-house. And an E-house is a fabricated enclosure where you could place the switchgear inside of that. And in that case, it could typically be NEMA 1 if you have that type of enclosure. Shutting down the electrical system for maintenance may not be economically feasible in industrial critical operation facilities. Therefore, switchgear with draw-out breakers are used. So that what makes draw-out breakers much more widely used is in case of a breaker failure, if a breaker goes bad. If it's a fixed mounted breaker, the copper bus, either the run backs or the risers, are going to be connected directly to the breaker. So if you had a breaker go bad that was fixed mounted, you'd have to completely isolate that bus in order to get in there, disconnect the breaker itself from the copper bus, and then remove it to replace. Whereas if you have a draw-out breaker is going to have what's called a cradle, and that cradle is going to be what's connected to the copper bus. So that allows you to remove that breaker and replace with new without having to go in and shut down all that bus work and make those changes that way. Depending on the facility's power requirements, switchboards or switchgear may be needed for the main distribution of equipment. All right, Sean. All right, so that concludes our training session there. I know I probably went through that kind of quick, but I wanted to save time for Q&A, so I'll turn it over to Sean. Sean, I'm not picking up. I can't hear you on the screen.
How about now? Is that better?
Yep, that's good. I got you.
All right. I'm gonna take this off because somehow this just crashed on me. Can you hear me still?
Yeah, I can hear you now.
Okay, perfect. So yeah, no, I was just saying, thanks a lot for breaking down the differences between the switchgear, switchboards, and panel boards. I know it can be quite confusing for some folks, especially if you're like a non-engineering type, or you're not into power integration, or you're not an OEM generator or engine manufacturer, to understand how all this kind of ties together. So from a lay person like myself, I appreciate you breaking it down to the in a simplistic way to where I can best understand it. So I know the audience appreciates that as well. So before I ask, we do have, let me see, 3 questions that came in that I will ask you. And before I jump into those 3 questions that we already have, I just want to remind everybody, if you do have a question, just click the Q&A tab and on your Zoom toolbar and just ask your question and we'll get it answered. Another way you can do it, because we are streaming live on Facebook, and I have that up as well, just make a comment in the comment section on Facebook and I'll see it, and then I'll give that question over to Jason as well. All questions, whether it be a fastball question or a softball question, are okay. We're here for you, and we're here to learn and digest and share information with the audience. So that's our main goal here. So first question, Jason. So what is a good example of a load that a switchboard will see?
Good question. So switchboards, you're still at the 480 volt level, and so you'll have 3-phase there, and oftentimes that's where you'll see ventilation motors or ventilation fan feeds, and then also motor loads such as fire pumps, water pumps, and things through a facility. So mostly motor loads is what I would think you would see, and then also then you would feed transformers, step down transformers from that point as well.
Okay. All right, I understand. The during the presentation, you also mentioned the LSIG, and if you didn't catch that, that was long time, short time, instantaneous, and ground fault is the acronym for LSG. So the question being, low voltage breakers cover LSIG. What about medium voltage breakers?
Oh, very good question. So when you're in the medium voltage, those particular set points, the strip units, are not local on the breaker. So the breaker itself is going to have a shunt trip coil. And so what you require then in the switchgear is a multifunction relay. So a multifunction relay is going to give you the versatility and ability to program a relay with many different devices and many different set points available. So they're going to receive voltage current inputs into the protective relay device, and then based on your programming and set points that you put in, you'll send a signal to that shunt trip coil to open and disconnect that breaker.
Okay. All right. Yeah, I'm reading a question here coming off of Zoom. So the question is, does the NEC classify transfer switches as switchgear? That's part 1 of the question. And then part 2 is, are transfer switches manufactured to the same UL ratings as other switchgear?
That's a good question. Actually, the UL ratings are going to be different on transfer switches in some aspects. What was the first part of that question again, Sean?
Yeah, the first part is, does the NEC classify transfer switches as switchgear?
I don't believe so. I definitely have to go back and look that one up again in the NEC, but I believe there's a different article for transfer switches, more so than switchgear.
Okay. All right. Well, I'll make a note of that and we'll get back with the
Yeah, let's
audience.
get back to that one.
Yeah. Okay. No problem. Okay. Here's an interesting question too, because I know a lot of folks out there are experiencing this, or the light bulb may have went off in their head about this, is that their current switchgear is rather old. You know, that's reliable, but it's old. So what would be the appropriate time to update your switchgear?
That's a good question. So, as the age of the switchgear increases, the risk of failure or an issue there with that gear increases. So I would suggest, if your switchgear is 10 to 20 years old, that you would contact an OEM manufacturer such as Enercon to have us take a look. We actually, I'll come out and do free site assessments and look at the gear and kind of give you an assessment on the age of the equipment and how it's functioning. And from that point, we can help assess that and see what would need to be upgraded and replaced and modernized. Also, upgrades also give you increased capabilities with your equipment. If it's not currently functioning as the facility needs it to, or doesn't have all the full functions that you would like to have, that can also be implemented during an upgrade as well.
Okay. All right. Here's a longer question that came in on the Q&A from Facebook, or not Facebook, Zoom. So the question is, would another distinction between panel boards and switchboards have to do with whether or not the board feeds another power distribution board versus only loads? For example, are panel boards strictly to feed loads, whereas switchboards can feed loads and or other distribution channels?
Yeah, that's a good question. So in the example that I showed, we went from switchgear to switchboard. And so once you're at the switchboard level, you're still at 480. So then the first question that came in about what loads would be fed off that. And we're three-phase 480. So that would be where motor, pumps, ventilation. And then from there, you could feed other 480 panels. So if you want to feed a 480 panel board from there, it may be in a different building or another floor within the facility. That's fine. And then if you want to step that down to a lower voltage, then that's where you would go through a transformer. And then onto that next level of panel.
Okay. All right. Appreciate it, Jason.
Mm-hmm.
Okay, here's another question. Are motor control centers considered switchboards? Are those like the same, or is there some differences there?
There's some differences. There's some similarities, but in differences. So motor control center, it's a similar looking panel. Excuse me. Sometimes it's thinner. Give me 1 second, Sean. Just gotta get a drink of water here. So a motor control center is going to contain what you would call a bucket. And inside of that bucket, you're going to have different controls for specific motors, and you'll have a switch there on the side. And you can fit quite a few of those in one lineup. But it is a bit different, and I believe there is different NEC guidelines for motor control centers.
Okay.
So if you were going to add a motor control center into that example we had, that would come in off of, you could do that directly off the switchgear, or you could run that through the switchboard.
Okay. All right. And we have a question from across the Atlantic Ocean. So this viewer wants to know via Facebook, does Enercon do any work in India?
Yes, we do. Yes, we've done some projects in the past in many different countries, and India included. Excuse me.
Yeah, just to elaborate on that. Yeah, we're 110 different countries across the globe. The only place we haven't been to yet is Australia. And I can think of many reasons to pay a visit to Australia. So Australia, if you're out there and you're watching, and you need some help and assistance on what it is that we do, give us a call, let us know. But yeah, all over the globe, 110 different countries, and India is definitely one of those countries. All right, it looks like, all right, here's another question. So let me bring it over here so I can see it better. What is the UL standard met by switchboards?
UL for switchboard. So I would recommend the UL 891 on dead front is what we would do for distribution. So for a low voltage, I would recommend the UL 891.
Okay, UL 891 is what Jason recommends for switchboards. Okay, I'm checking the board. Are there any more questions? We do have a little bit more time. We try to get done with these things in under an hour because we know people are busy, so it's kind of short, impactful, and sweet. There's a lot of information, like Jason alluded to earlier, about the differences between the three items there and how it all interacts together. We do really appreciate your questions, so I'm just going to leave it open for about one more minute while, if somebody is typing, we get that and we'll get that question answered. So one of the audience members, Jason, wants basically an encore presentation. That's what I'm gonna call it. So he wants just a quick recap again on the difference between switchgear and switchboard. So there's those two, switchgear and switchboard, just a quick recap summary of the differences between those two.
Sure. So the switchgear is the first piece of equipment in line, and it's going to contain your utility coming in, and your standby generators would be cabled into the switchgear, and then those first feeds into the rest of the plant. But switchgear is also going to contain the intelligent controls and touch screens or visuals of gathering other information from the plant. So you're going to see more intelligent controls within the switchgear. Switchboards are mostly just going to be just breakers and just feeds. So you're not going to see too much instrumentation or controls in that aspect. It's mostly going to be manually operated for the most part and contain thermal mag circuit breakers.
Okay. And is there a UL listing for medium voltage switchgear?
Yes. So we would classify that as UL metal clad medium voltage switchgear. And that's the file that name that Enercon would cover would be UL metal clad switchgear.
Okay, so UL metal clad switchgear.
Correct.
Okay. Thank you, audience member, for that question. Any more questions out there? All right, it's still not too late, but as we're waiting, I just want to remind everybody that you can go to our Facebook page and like the page and subscribe to the page, and then you'll get notifications of anything that we post here at Enercon Engineering. And we do kind of share our information with the world that way is one means. Another means is the YouTube channel that I mentioned earlier, and you can go into the chat room and pick up that link and then drop it into your browser and go and subscribe to our YouTube page, and you'll see any videos that we produce dealing with the webinar or any other topics going on inside of Enercon, so you can see and follow us and see and just check us out and see what we have going on. And I don't see any more questions other than thank you, Jason, for being here. So I want to echo that sentiment. I really appreciate you, Jason, for taking time out of your busy day. Jason, again, he's in sales, so he's a road warrior. So he's on the West Coast. He's got the West Coast territory, so he's got tough duty over there. We know how the sun shines in California and Oregon and Washington and all those areas. So, but he put in a lot of time and effort in presenting his material. So we really appreciate you, Jason, for doing this for us and for everybody that's attending. And for you attendees that will see this later on, because this is going to be recorded again and posted on YouTube. So this video will live forever as long as we have that YouTube page. So stay plugged in. We're all over social media. So Facebook, YouTube, Twitter, even Instagram. You can find us there as well. So those are just a few different means to stay plugged into what Enercon is doing. And I also want to let you know that once we wrap things up, you're going to receive a very short survey, very short. I mean, it should take you like 1 minute to do it. I really would appreciate you taking the time to do it. It's multiple choice, if that makes it easier for you. 5 short questions, and you answer those questions, and it's anonymous, and we get some feedback on how the presentation went today. We use your feedback to adjust for the next session that we have. Speaking of next sessions, the next session, whoops, I went too fast. We're going to be discussing the benefits of microgrids. So that's going to be on March 23rd at 10 o'clock Central Time. So March 23rd, 10 o'clock Central Time is when we're going to be discussing the benefits of microgrids. So if you heard about microgrids, or you want to know more about microgrids, or you just want to know why microgrids itself, then please tune in to the 23rd session in March. You also get an email invite from me since you joined this one and you participated in this one. So probably like next week, you'll get a special invite just for you to attend. And that's a shareable invite. So you can share that with your friends, your coworkers, or whomever that you think may ought to hear this information and would like to attend, because we're all about just education and informing the community. So invite whoever you would like. So with that, Jason and I want to say you guys have a great week. Rest of your week. It's an exciting year for 21. So we are very excited. I'm very pumped to get this year started. And we look forward to dialoguing with you here in the near future. And we will see you on March 23rd. So with that, Jason, thank you for your time and your efforts, and great day.